We're on to question 4.2. The graphs of f and g are sketched below. E and h are the x-intercept of f. C is the y-intercept of f and lies on the asymptote of g. The two graphs intersect at D, the turning point of f. Question 4.2.1. Write down the y-coordinate, just the y-coordinate of C. So what do we know about C? C is the parabola which cuts the y-axis. So how do we find y? We make x equal to 0. So y equals 0 squared minus 4 times 0 minus 5. Y therefore equals minus 5. Or we could have alternatively just gone and said, okay, y is equal to minus 5. So this point are 0 and minus 5. Question 4.2.2. Determine the coordinates of D. Well, what do we know about D? D is also the turning point of F. We can see over here, D is the turning point of F. So what do? We find the value of X, substitute X, and we'll find Y. So X equals minus B over 2A. Minus, what's B? B is minus 4. 2. And what is A? A is the hidden 1. That'll equal minus 4 of 2. That'll equal minus 2. Therefore, x is equal to 2. Now that we know what x is, y will equal to x squared minus 4x minus 5. Y will equal to 2 squared minus 4 times that by 2 minus 5. Y will equal 4 minus 8 minus 5. Therefore, y is equal to minus 9. That would mean that the turning point is 2 minus 9. That also means that D is 2 minus 9. Question 4.2.3. Determine the values of A and Q. So we know that in an exponential function, the Q represents the Y value of the asymptote. And we worked this out previously, which is point C on the graph. And we can see there that the Y value is minus 5. Therefore, Q is equal to minus 5. So that's the first part of the question answered. The next part is we have to determine what the variable A is equal to. We know that the turning point at D intersects with the graph G, and therefore we've got an X and a Y value. So if we look at this is Y equal to A times 2 to the power X minus 5. Y is minus 9, 2, and X is 2. This will equal minus 9 equal to A to the power 4 minus 5. Minus 9 plus 5 equals A to the power A times 4. That'll equal minus 4 over 4, which equals A. Therefore, A equals minus 1. Question 4.2.4. Write down the range of G. So from the graph, we can see Y is an element of minimum value will be negative infinity, and the maximum value will be minus 5. Question 4.2.5. Determine the value of k for which the value of fx minus k will always be positive. So let's start off by figuring out what the value of fx is. And in order to do that, we just substitute the value x into the equation. And we can use the turning point, which we already figured out. So fx equals 2 squared minus 4 times 2 minus 5. Fx equals 4 minus 8 minus 5. Therefore, fx equals minus 9. Now we have to prove what they're asking. They want fx minus k to be a positive value. We know that fx is minus 9. There's a minus, and then some value to always make this a positive outcome. If we look, we can go minus 9 minus 10, and that will equal a positive value, which is 1. Anything, we can go fx, we can go minus 9 minus 11, and that'll equal 2. So what we're saying is, as long as k is less than minus 9, we'll have a positive value, because at minus 9, that'll equal minus 9 plus 9, and that'll equal 0. So at 9, we're not a positive value. So as long as k is less than minus 9, we'll have a positive outcome. Thank you for watching the video. If you have any questions, please drop your question in the questions below. We'll read and respond as soon as possible. If you need more help with math, please click the link below. That goes to my channel and go view what we have available there.